So he is so critical to AOSH. Without his leadership, without his direction, without his involvement, without his care, without his passion, and without his spirit, AOSH would not be the organization that it is today. So I thank him for that alone. Now, he's been president of AOSH, he's been on the AOSH board forever and ever, and he's doing amazing things. And he's got a great story to tell. I'm glad you're all going to be able to hear it because I heard a little bit of it at the last AOSH meeting. And I have been looking into some various things, sciences, etc. And then all of a sudden Lee grabbed me one day and he says, I got to tell you about something. And he blew my mind with what he told me. He will do the same for you now. Lee, how are you doing? You all set?
I'm almost set.
Okay. By the way, treat him nice, because he's my roommate. Okay? And I don't even want to think about how bad that could be if there's trouble. All right? So far we're getting along, you know. But anyway, so are you all set to go?
I think I am. Just
ladies and gentlemen, yeah, please give it up for Lee Ostler.
Thank you, sir. Just testing the mic. You okay with that?
Good, baby.
Okay.
Sound good? Good.
This is a treat and a pleasure for me to be with you today and to talk about something new that has come along that we're calling Redox Dentistry. This is going to be a high elevation flyover, and because there's so much of the with this, and so I'm open. You can ask me questions all day. I'll be here. But this is I think an important part of the oral systemic message and the conversation. It's interesting to see new products and new companies and new ideas come along that just ring true. My disclosure is ASEA. This is a company that makes redox signaling molecules, which we will talk about today. And I subtitled this presentation, Connecting the Dots. And hopefully you'll understand more about that as we go along. But also it's about get your cells talking. This is cell talk. This is the communication that's going on there. I'd like to introduce you to my wife, because if it weren't for her, my lovely bride, this wouldn't be happening and we wouldn't be introducing Redox Dentistry. She's had a long storied health crisis for 4 decades. 2 brain surgeries, many other surgeries, chronically ill, and basically for 30 years I've been a caretaker. That's kind of been my life. And in October of this last year, we were with her physician, and I was like, what else can we do? She's plateauing. I'm not sure what we can accomplish here. And he said, you need to go look up some redox signaling molecules. I thought I knew what redox meant because I'd heard it in college, the term in chemistry classes. But I was like, okay, so I hit the internet and did a deep dive, because those of you who know me, I'm a little bit OCD about wanting to know the science. I've got to know mechanism of actions. If that doesn't work for me, then so I've got into this and I started to learn this new thing. And so I said, all right, I'll get some. He said it, so we'll just do it. And so a little bit of leap of faith. We got her some, and it was literally within 36 hours. It was like flipping a switch. And it was like, wow, there's something, just like, I need to know more even. 2 weeks later, I'm at AOSH in Vegas with the American College for Advancement Medicine. How many were there? So maybe 10% of the room. And these integrated physicians were there, and they had a track, and they talked about cellular health, cellular detox, gut health, redox biochemistry. And for all of the dental folks side of the coin, it was like kind of a new thing. To them, it was a little more understood. And that was the second week of November. This is what I came home to. And she'd been maybe 3 weeks using these redox signaling molecules. And 2 weeks later, I got to take her on a date. That was the first time she'd worn makeup in a long, long time. We're walking into the grocery store one day, and she said, this may be an interesting segue from the previous presentation. She looked at me as we're walking into the store, and she says, I'm not depressed anymore. I go, really? How do you know? She goes, I am not depressed. I go, I know, but how do you know? I was like, I'm really analytical. And she looked at me like, kind of, you dummy. It's like, I feel joy. I don't feel sad. And I thought, that's worth the price of admission. So this is what got my attention. This is what caused me to take a really deep dive to try to understand this. Our outline today is going to be quick. We're going to talk about what is redox. We'll start there. And we're going to end up with how I believe we can apply this to the clinical world, the real world of dentistry. So redox means reduction oxidation. It's just a contrived word that represents both of those. How many remember this in chemistry? Right? Reduction, oxidation. Basically, it's real simple. You have an oxidizing agent, like let's just call it oxygen. It's hungry to take a molecule. It wants an electron from whatever it can get it from, and when in the process of doing that, it will destroy that one. So there's a reducing agent. That's like an antioxidant, or there's many other molecules that are willing to give up an electron. It says, okay, I'll give it to you. So it's about the movement and transfer of electrons from a reducing agent to an oxidizing agent, wherein the oxidizing agent becomes reduced and the reducing agent becomes oxidized. And that's just a continual trillion times a second process. Okay? This movement of electrons is what we call life. If that didn't happen, we wouldn't be alive. This is communication. This is signaling that's going on. We've seen this in real world. We leave a wrench out or whatever, and iron becomes exposed to oxygen in the presence of moisture, and we get iron oxide. Those of you who are into fruits and stuff like that, which we should all be, but you cut the darn apple or the banana, and what happens if you allow it to sit around? It turns brown. There's the science why. I'm not going to bore you with the details. But what happens when we take the cut fruit and we give it an antioxidant? We put it in a bath with some citric acid or fruit fresh or lemon juice or whatever, and now that's covering the sins of oxidation and it stays fresh, right? We're familiar with that, right? In the body, the same thing is happening. We call it biological rusting, if you will. So oxidative stress is happening all the time. When the oxidation outweighs the reduction, and I develop this oxidative stress state. It's responsible for us getting wrinkles, for us getting sick, eventually dying, and all along, all the way through our life. And it affects every cell of our body. This is also a part of life. Redox signaling molecules. Redox signaling molecules are an important part. We know about the body has organs, which has made up of tissues, which is made up of cellular processes following metabolic pathways that sit on top of the genes, right? You get that hierarchy? We are our genes, right? Okay, there's one other aspect to this, and that is how the genes express themselves. Just because you have a cancer gene doesn't mean you're going to get cancer. Just because there's some genes that are fixed, your skin color, your eye color, trisomy 21, Downs. I mean, there's some genes that don't change, they're pretty fixed. But then all the other ones, the majority of them, have some level of expressibility. Whether they activate or don't activate is a function of epigenetic redox signaling. And this is kind of the new front. There's really no one thing that owns that. This is the root cause of all dysfunction, because it's cellular dysfunction when those pathways aren't working. So these signaling messengers, there's multiple, numerous of them, and we're just going to focus on, we talk a lot about these, and especially right here in the interleukins. I mean, this is the inflammatory cytokine cascade. How many hanging around AH understand inflammatory burden, cytokine cascade, interleukin 1, 6? How many, I don't know what I'm talking about? Okay. That's what periodontal disease does, okay? That's the whole point. And we've been studying that a lot in AH. But I'm going to talk about this top level here, the superoxides, the hydrogen peroxides, hypochlorous, nitric oxide. Those are tiny molecules that also act as signaling. They're made in the cell. The only thing the cell has available to it is what it's living in, which is saline, normal saline, right? And saline is salt and water. There's some nitrogen in there. And so the mitochondria has this way of making all of these molecules and doing things with them in the signaling. Everything from superoxides to hypochlorites, to hypochlorates, hypochlorous, oxygen derivatives like ozone, peroxide, nitric oxide, and so forth. Those are all the possible combinations, and there's a couple dozen of those that the cell uses to help in this electron transport process, okay, the communication. So what are redox signaling molecules? They are charged bioactive molecules. Some of them have positive and negative charges. They're produced in the mitochondria, and their role is communication both within and between cells. And this is next line is their function is that they detect, they defend, they repair, and they replace. That is the definition of cellular health at a microscopic cellular level. They're foundation to all cellular processes in one way or another, including our immune system, protein synthesis, gene expression. They activate the antioxidants, they activate the foods, the polyphenols, all these things that we get in our foods, and anything that we would acquire from plant-derived antioxidants. But they're also biocidal. These are the very molecules that our immune system uses to take out bad bacteria. They kill the pathogens. That's their function. That's where the hypochlorite, and these reactive oxygen species come from. And the interesting thing now that makes this possible to discuss is that they've now been stabilized because they live nanoseconds in the cell. They've now been created and they're stabilized and they can be supplemented, which opens up a new opportunity here. So we're going to talk now about the science of redox really quickly. I looked at this when I saw it. I've been looking for this picture for a long time. When I saw it, I was like, why don't you just take this sliver out, you know? I don't know why you put a Band-Aid over a sliver, but you can see the reaction there of the skin, right? There's an innate immune system response to that when there's an injury, there's things happening to the cells and the tissue, and this is all choreographed with these signaling molecules in one version or another to activate our immune system to restore health here. Well, that was an acute thing because you can obviously take the sliver out. But this is more chronic. This is what we see day in and day out, and it's like when there's a chronic presence of this stuff. What's spinning up? What's going on behind the scenes here? We know from these from the studies, Porphyromonas gingivalis, the lipoprotein polysaccharide envelope around it, and what happens there. And then this is kind of a magic slide because this is really the essence of this, is that the lipopolysaccharides complex with the binding protein to make a pathogen-associated molecular pattern that then complexes with a toll-like receptor that then does this magical thing of activating messengers inside the cell to activate nuclear factor kappa beta, which is a translation and translocation factor that goes into the DNA and transcribes and translates for a certain class of proteins that we call cytokines. And again, this is where we live, because these buggers right here are what cause the inflammatory problems that we have, that we've linked to all the things that we say in the oral systemic connection. Right? Everything going on here has that basement foundation or root cause thing of signaling. If it wasn't signaling, we wouldn't get that to happen. It's got to happen at one level or another. If we dive into the cell, we see a mitochondria. This is where the electron transport chain is for oxidative phosphorylation. This is what's creating ATP, which is the energy molecule with the byproducts of water and carbon dioxide. That's just basic physiology. But the other thing that's happening is I'm creating these redox molecules, these signaling molecules, reduction agents that fight free radicals. They're loaning electrons. And those that are reactive oxygen species that are taking the viruses out and the bacteria out and the fungi out and all the toxic stuff out, those work together. So this is all going on inside the cell, but it's the mitochondria that is producing the lion's share of these signaling molecules. And so what happens here is while all this is going on inside the cell, we have this transcription going on where they translocate into the nucleus to affect gene expression. The gene has got to interpret this do we get excited about it? Do we shut it down? Do we go left? Do we go right? And that's all managed in this translocation of these transcription factors. There's two that we focus on. One is the NFKB, nuclear factor kappa beta, and it's the phase 1 responder. It's going in there in response to the presence of superoxides, hydrogen peroxides, and others. It translocates, and that is a sure, certain, for certain, indicator that there's been a toxic insult in the cell. There's been oxidative stress that's lingering, and so that transcription factor goes into into where the genes are in the DNA. It turns on, and we produce all of the downstream cascade of immune system response to try and deal with whatever that is. The phase 2 responder is the nuclear factor erythroid-derived 2, NRF2. And this is going in, this is the same thing, it translocates into the gene, into the nucleus where the DNA is, and it starts to code for antioxidants that are native. These are the ones we make. We originate them, and those are called principally glutathione and superoxide dismutase. And what we've discovered is that there's one exception, because these NRF2 translocation factors always follow the big one, the nuclear factor kappa beta. They always follow that because we're trying to defend, repair, and replace. We're trying to restore health to the cell or take it out and replace it. But when we put supplemented signaling molecules in play, especially at low concentrations, it does not require the activation of the inflammatory cascade. The nuclear factor kappa beta is left untouched. So we can go in there and we can now selectively upregulate the expression for glutathione and superoxide dismutase, which are major. Glutathione is the major mother antioxidant that's made in the body. It's the master one. So when we're living our life and we have all this toxic stuff in our environment, we don't eat right, we have stress, pollution, we're aging and so forth, what's happening is that every decade that we live after puberty, we're losing about 10% per decade of our mitochondrial efficiency. We're not making glutathione like we need to, okay? And so we wind up with cell dysfunction. A good analogy of this is normal. We all have smoke. We all have some waste product. But then when it gets out of hand, we need to call the fire department. It's an easy metaphor. In the cell, what we've stained for here are these translation factors, the NRFK, the nuclear factor kappa beta, and NRF2. We've stained for those, and we find out that when they're placed under a stress, when there's oxidation, they migrate to and are now found in the nucleus. Again, this is that sure sign that there's been something toxic and exposed to that cell. And so what the cell does is it says, hey, that's going on. So we're okay because we're in balance in the cell. We had the damage. We need to now signal to get the crew to show up to fix this thing. We need to activate some pathway so that the labor and the materials can show up to do the repair and the replace. And if I have an impairment in this area, whether it's 0 or 100, but it's never 0 and 100, it's like somewhere in between, I'm going to have a less efficient ability to activate that. And so redox signaling allows the cells to function the way they were designed to work by restoring this capability. In a healthy cell, there's a balance of oxidants and reductants. And when they're in balance, and when I have a protective layer of these protein thiols called glutathione, then the cell stays in balance and it's happy. When I start to get out of balance and I have more oxidative agents in here, it signals. And so if I can't repair it, then there's another signaling that goes out there that says, take it out. This is called apoptosis. It's programmed cell suicide. I want to get rid of that dysfunctional cell. After a couple hours in an oxidative state, it's not really healthy. And so what happens is I now signal to my extracellular partners on either side of me, surrounding me, to say, you need to go through mitosis. You need to subdivide and replace what's bad with a healthy version of yourself so I can restore. And so now I'm restored back here. And so here's in a summary slide, this is what we just said. We have oxidative stress where there's an increase in oxidants that are not balanced. It activates these transcription factors that then code for cytokines to activate the immune system. And then what happens is it either repairs successfully restores the oxidative balance, or it replaces them. And it does so by creating new blood vessels, angiogenesis, fibroid scar tissue, cell turnover. That's all programmed in this process. This is the healing process at a cellular or microscopic level. So what are the studies behind this? This is new and this is raw. Those of you familiar with some of what I've done, I wrote a book here. I've got 2 or 3 of these, but there's 1,246 abstracts that I collected so I could give this to physicians. Okay, this is my physician's resource manual. Not one of them proves that periodontal disease causes heart disease, dementia, brain amyloids, kidney disease, diabetes. Not one of them. That's why we call it a connection. And yet, look, we've assembled here and have for almost 10 years on the premise that the preponderance of evidence, some of it quite circumstantial, substantially validates our belief that when you have dirty gums and you can't breathe well and so forth, that activates this pathway that produces inflammatory burden in the body. And what do we know happens when there's inflammatory burden?
Disease.
We get heart disease, don't we? So we can't say that gum disease cures heart disease. But we can say a whole lot about the processes in between, and that's what's going on here. So in this arena, one of the early prime studies here was a gene study that was done that showed an increase in gene expression. That's that signaling. It's telling the gene you better do something about this. It increased in a positive direction on the 5 genes that were studied between 20 and 31%. We thought, well, if it was only 1%, that might be interesting, but this is pretty significant. Just one of those we're going to pick out. One of those had 15 gene pathways that was responsible for it. Serotonin. Think about these as I tick them off. Think about if you had an improvement of 20, 25, 30% in this pathway, how would that affect your life? Connect those dots. Serotonin support, neuron synapse support, antioxidant health, vascular health, endothelial function, hormone modulation, insulin signaling, immune system, transcription gene expression. If we can increase and elevate that, any of those to that degree, would that have a downstream effect on something? You follow what I'm saying? So we can connect those dots, and so in this particular study, the 5 things that they came away with was the immune system, the inflammatory pathway reduction, vascular health, digestive health, and hormone modulation. You see the connecting of the dots. We can't say any of this causes or fixes a disease or cures or has a health claim to it. We're not allowed to do that. But we can connect the dots, can't we? Just like we've been doing for 10 years in this academy. Another study was done, because we can study the metabolomics, is that they gave redox signaling molecules to a group of overweight women and found that 7 days ahead of their exercise, they were freeing up fatty acids. Where do fatty acids come from? Anybody know fat? Yeah, triglycerides, right? It was beta oxidizing fatty acids, which is the catabolic destruction, separating them apart, making them available for Krebs cycle. And then it was preferentially using those fatty acids first in the Krebs cycle pathway before glucose. When we go out and we carb load and do great exercise and it's burning that, what does it create? That's why you don't feel good the next day. It's creating lactic acid. And a lot of waste, there's exhaust in there that we have to kind of like undo. The recovery period is tough. Well, they found here that not only were they reducing oxidized LDL and serum cholesterol and the markers for oxidative stress, they were in this Krebs cycle, all these metabolomic entities were being used preferentially to glucose, which goes through glycolysis to make pyruvate, right? That's the glycolysis pathway in Krebs. We were now using selectively first, preferentially, fatty acids to burn. Now, can you connect those dots? If that's happening, what's going to happen to my diabetes? What's going to happen to my weight? What's going to happen to my heart disease? Is it any wonder why all these markers are starting to go down? So what is redox dentistry? That's just a little toe dipped in the water. Okay, there's much more. We don't really have time, but What is redox dentistry? When I was in Vegas and I listened to this conversation, here we have signaling molecules that have this dual function. They were biocidal selectively against pathogens, which is why they're using them in the gut to deal with the endotoxic load that happens in the gut, getting cell walls, the leaky gut thing, or like getting the cell wall junctions together, protecting the immune system barrier on the other side of the intestinal wall. And I'm listening to this, I mean, wait, these are these are selectively biocidal. We have pathogens in the mouth. And I have commensals, healthy bacteria in the mouth, and we want to keep those. Yet everything I use right now, number one, I can't swallow. It's toxic and has side effects to it. The other thing is everything we've been just talking about is because I can upregulate genetic expression, I can now advance and enhance cellular healing. Well, that's what I want as a dentist when I cut a tooth surface, right? That's what I want. So on the biocidal thing, this is out of the foundational research. This was a company that was creating a product on the pharmaceutical side for things like HIV, sepsis, cystic fibrosis, actually, interestingly, medical dental instrument sterilization. This is back, I think, before OSHA would have had a say in that. But that was the path they were on. And they realized that they couldn't continue in that path because they couldn't get an LD50 established. They couldn't get half the mice to die. And so they were blocked, they ran out of money. Besides, every claim you make has got to have about $500 million worth of research over 10 years to show, to make a claim, and anything else that it does is off-label, you can't talk about it. So they flipped this onto the supplement side. But before they did that, this is what surfaced. This is what got my attention. Staph aureus, Pseudomonas aeruginosa, Legionella pneumophila, and Candida albicans. These are some bad boy bugs. Within 60 seconds, 1 minute of exposure, all the organisms died. Even at partial dilutions, 99.9% of these were handled. And I'm thinking, no wonder these physicians, these people that have vetted this, are using this for gut health to balance things in the gut, like small intestinal bacterial overload and all the issues with leaky gut and so forth. So again, when you're looking at this, and when I've got this oxidative stress, and this is the healing process. I just did something here. There we go. And you think that through, and you think that's the process. Just in review, if I can do that in the mouth, wouldn't that be cool? Wouldn't it be cool if this was lethal to pathogenic bacteria, sparing the commensals, elevating the natural immune system in the mouth, non-toxic, not causing and possibly reducing inflammation locally, used topically on the gingival tissues. It's an oral rinse, advisable to swallow it because of the systemic effect, and it's pH neutral, which means it's safe. I can use on cut tooth surface. I'm not etching teeth with it. So this is what I do, and this is what can be done. We can use redox signaling molecules on cut tooth surfaces. Think of the dentinal tubules and what's on the other end of the tubule in the middle of the tooth. If I could help it to reduce its inflammation and clean things up in the bacteria. Pre- and post-surgical rinse, autoimmune disorders, cancer, side effects, mucositis issues, injury and trauma, periodontal treatment. Just think this through. It's like, what could this do? It's not just activating gene expression for antioxidant creation. It's also killing the bad critters. So just a quick slide. This isn't meant to be a deep tutorial on the clinical side, but there's a gel, and I wipe that on. I just use a medicine dose cup, put some liquid in it. I soak, this is a crown prep back here. I put a little cotton, half a 2x2 in there, soak it. I pack it around the tooth while I'm making the temporary, so it's bathing in this stuff. I take it off, rinse it off, put some chlorhexidine because I'm not doing anything different in my standard protocol. I'm just adding this to it. And I'm finding that this is very helpful for these people. They're coming back and it doesn't hurt. These are some of the things I figured. You can't touch metal with this because metal will kind of like deactivate those charged molecules. So it has to be in plastic or paper. And so you get some plastic syringes, an endo aspirator, and just think of that. You could send this home, a 5 milliliter syringe with your patient, where they could do their own subgingival irrigation with a biocidal agent that would upregulate cell healing. Imagine that. This is a lady, this is after 3 days. She is really, really very, very sick. I had patients who were well, sick, and sick. And she is sick. and she is immensely sick. And she came to me because that was a temporary crown for 3 months because the dentist in Texas where she worked, that's all he could get done because of her health issues. So we finished her up, and I said, look, I don't know, just try this. She is, but if you had seen that before, you just have to trust me, but before, this was like a fire engine red. She was hurting, it was burning mouth syndrome. She had all these lesions on her tongue, they were very well demarcated, you can kind of see the vestiges of it. But that was very impressive. We just did this on Monday, a Freenan release, and we're applying the gel here. I wish I just got the 2 or 3 day follow-up, and it's like, it's feeling a little bit better, no pain. We did a filling on her at the same time, but that's what hurts. This was fine. So again, what is Redox Dentistry? It's this dual action in the mouth that supports systemic health. This is the most pure oral systemic play I think I've come across, and it's not discounting others. This is what activates healing. This is what activates antioxidants. This is what makes vitamins work better, your spinach work better. It's what makes sleep work better, which is what I've noticed is one of the things. Finally, the doctor of the future will give no medicine, but will interest his patients in the care of the human frame and diet and the cause and prevention of disease. We've all read that before. And I looked at that and I thought, we talk about root cause. What's the root cause? If we can get down to the root cause below everything else, this is a root solution level. And if I can manipulate that in any way and upregulate those healing processes in an accelerated way, everybody wins. So I have redoxdentistry.com. I would urge you to go there. I wrote a manual on how to do this clinically. There's protocols in here. You can download it and read it through. I have cards over here. This is what I give my patient that helps describe what it is that we did. And I thank you for your time and your attention. Thank you.
Thank you so much, Dr. Ostler. That was amazing. And that's why I love American Academy of Oral Systemic Health.